Okay, so this is a slightly more difficult problem, okay, and if you look at this, we're not given the amount of carbon, hydrogen and oxygen, so there's no empirical formula, which means you've got to delve a little bit deeper into the mass spectrum, okay, because that would give you some more information. If literally there was the empirical formula, you probably wouldn't have to. Okay, so let's look at the M+. Okay, so that M+ is down there, which I'm showing for you. It'll be obvious in the exam, 102. So write that down if you're doing it. Okay, and then we look at the tallest peaks of each group. So if we look at those, that is tallest peak of 43. Now, 43, we don't know what it is, but it can be a CH3CO, if you add that together. It can be a propyl group. Okay, so let's keep that in mind. Which one? We're going to use that later. Okay, so which one will it be? And you've got to get used to saying, well, what is 43? According to what you've got. And there are your two options. This one is really important. So this one, it came up in an AS exam, the actual AS exam that was done 1 year. And they had to differentiate between pentan 1-ol and pentan 2-ol. So you can differentiate between terminal or primary alcohols and secondary alcohols. And you can do that by literally this 31 peak. So a secondary alcohol will not have the 31 peak, where a primary will. So if you're writing notes down from this video, that's something I would write down, okay? 31, which is your primary alcohol. Now, from that point, we can just park that information and then go on to the next bit, okay? So there we go, 102. So we've got 102, the molecular mass, and we're going to look at our carbon NMR. Now, carbon NMR tells us how many environments we've got, okay? And we've got 5, you can see 5. And it also tells us what kind of carbons we have. So if you look at your data sheet, you'll see this is a C double bond O, this is probably a CO, and then the rest are carbon bonds. Okay, but we know we've got 5 carbons to deal with, so that gives us a formula to work off, okay? And that's our formula to work off. We don't know the H, we don't know the O, okay? Now, moving forward, looking at an IR. In an IR, we've got a very clear OH, and this is in the position, if you look at your data sheet, again, it's in the position of the alcohol, okay? Carboxylic acid is around about here, okay? Subtle difference. And this is your CH. So if this was a OH for a carboxylic acid, it would be rounded and it would be around about this area here. But it's not, it's an alcohol. Okay, so we've also got the C double bond O, so we probably don't have a carboxylic acid, which means we must have a ketone or an aldehyde. So think of that, again, keep these things in mind. If you're writing notes down, write ketone or aldehyde, so at the last bit you can try and figure it out for yourself and not just me. So we've got all that information now, and we're going straight into the NMR. Now, I'm quickly going through the NMR because it's very hard for you to see, so I'm going to label it all for you. This still doesn't give you the final structure, so still stop the video and try and make your final structure, because you can do that right now instead of waiting for me. Now, first of all, if we look here, we have got our doublet with a 3. So doublet with 3 means it's a CH3 next to a CH. So the doublet says it's next to a CH, and the 3 says it's a CH3. Then the singlet is a 3, which means it's a CH3, and the CH3 is next to a carbon with no hydrogens on it. Okay? So hextet. Hextet is the next one, and we can see it up here, and it's a 1, so it makes sense that it was next to a CH2 and next to a CH3, because 3 plus 2 is 5, 5 plus 1 is 6. So we have got 6 in terms of a hextet. Now, go to the next one. Another singlet is underneath there, and it's a 1. And we're thinking, because there's oxygen around and we haven't really talked about oxygen very much, it's probably an OH. Okay, next thing is the doublet, and the doublet with a 2 by it, doublet with a 2 by it, basically must be the CH2 that is on this big thing. So it's next to the CH, so it's a doublet. So we've got all these different things, and we're going to put them together. But again, stop the video, don't just watch me, and try and do it yourself. So let's get rid of that. Okay, and there we have it, and let's start putting something together. So first of all, I'm going to write something down from earlier. Well, clear something up from earlier, this bit here, which is 31. Okay, so we just go right like that. Okay, and there you have that. Okay. We also know from earlier that there was a 43 peak that could be a propyl group. Now I can't see a propyl group in any of these, so that can't be there. Okay, but there was one that said it was CH3CO plus, okay? And that is going to be equal to our 43, okay? So if that is the case, we've got CH3O. Now, that's the end, and this is an end. So therefore, I'm going to draw, okay, there we go. There we go. So we've got two ends. We need to fit the bit in the middle. Okay, so what we can do also is we can look at the number of carbons in this, and we can say, well, does it fit normally, the overall? But we don't know the overall at the moment. So but we do know this. We know we've got 5 different carbon environments. So if you look at this, this tells us our hydrogen environments. So we've got 1, 2, 3, 4. So that's the rest, and we've got this oxygen, this OH, okay, but let's not count that. So the carbon chain, we're going to find out the carbon chain. So we've got 3 carbons, okay, that are accounted for, and we've got 1 carbon, which means we know we have 5 carbons, which means missing 1 carbon. So there must be a carbon in there that doesn't have any hydrogens on, that potentially has an oxygen on, because this thing here is connected in some way to something that has no hydrogens on. So I'm going to guess, it's not really a guess, but imagine you're in the exam and you guess, I'll put a CO there, because you've got this up here as well. So you've got those 2 bits of evidence that I spoke about that gives you the idea that you've got a C double bond O there. Now that means we have done this bit here, okay, and we've got to fit in somewhere the rest of it that's coming along, okay? So we've got to fit in somewhere. Now this CH2 probably is the CH2 next to this. So that makes sense that that is bonded to, okay? So if you look at it, we have got this CH3CH, CH, CH2. So that means basically I'm going to have a H and I'm going to have a CH3 like that. And what you can do is you can have a little check, and I'll have a little check for you. Okay, and just check. And this is what I do in the exam. This is what I suggest you do in the exam. What am I going to get here? I'm going to get a singlet. Do I get a singlet over here? Well, I get a singlet over here. That's very good. Right, then I get this one. Right, is that a doublet? Oh, that's a doublet. Does it say doublet over here? Right, okay. It does say doublet, and it does say doublet right down here. There you go. Right, okay, we've got this one. That's next to 2, and that's next to 3. That's going to be a hextet. Do I have a hextet over here? Yes, I do have a hextet. This one is next to, oh, it's going to be a doublet. Okay, so that's doublet. Do I have another doublet there? Okay, I do have another doublet there. So look, I've got all of these and I've ticked them off. So this would suggest that I am correct. And probably because I know, because I'm doing the video, I am. Okay, right. So that is your example and your second example. If you want to do another one, go on to video 3.